Welcome to my channel. Computer architecture is one of the most fascinating fields in computing because it reveals how every instruction, process, and operation inside a computer actually works. In today's video, you will learn how to understand computer architecture in a simple, structured, and highly practical way, even if you are just beginning your journey. This long video has been crafted to guide you step by step, helping you build a solid foundation that will support your growth in more advanced computing concepts. Computer architecture focuses on how hardware and software interact, how data is processed, and how the computer performs millions of operations in a very short time. By understanding computer architecture deeply, you gain the ability to troubleshoot, optimize performance, interpret system behavior, and even build your own computing systems. This knowledge empowers you to become a better programmer, engineer, or technician because you begin to think like the machine itself. To begin, it is important to understand why computer architecture matters. Every program you use, from your browser to your video editor, runs through interconnected components such as the processor, memory, buses, and storage. When you learn how these components work and communicate, you gain insights that elevate your ability to solve problems and build efficient systems. This understanding is essential for careers in software development, computer engineering, cybersecurity, artificial intelligence, and more. One of the first core topics is the central processing unit. The central processing unit is the brain of the computer and it executes instructions from software. Learning about the central processing unit involves exploring control units, arithmetic logic units, and registers. When you understand how instructions are fetched, decoded, and executed, you become capable of optimizing your code, analyzing performance bottlenecks, and understanding why certain operations are faster than others. Memory hierarchy is another vital area of computer architecture. Memory includes registers, cache memory, random access memory, and storage. You will learn why cache memory exists, how it speeds up processing, and why random access memory cannot permanently hold data. Memory hierarchy is designed to balance cost, speed, and capacity, and understanding it helps you build systems and write programs that perform efficiently. Input and output systems are also fundamental. The flow of data between peripherals and the central processing unit is managed by controllers, buses, and protocols. When you learn how these input and output systems work, you begin to understand device communication, resource allocation, and how operating systems manage hardware. This knowledge is essential for understanding performance, troubleshooting device issues, and working with embedded systems. Instruction set architecture plays a major role in how computers execute commands. Instruction set architecture defines the set of instructions a processor can understand. You will learn about instruction formats, addressing modes, and the difference between reduced instruction set computers and complex instruction set computers. Understanding instruction set architecture helps you think in low-level operations and improves your ability to work with assemblers, compilers, and system-level code. At this stage, if this video is interesting, take a moment to subscribe to my channel to stay updated. Turn on notifications so that you will not miss my next video. And engage with my video by liking, commenting, and sharing it. Let us now continue with microarchitecture. Microarchitecture describes how the instruction set architecture is implemented in hardware. You will learn about pipelines, execution units, and microoperations. Pipelining is an important concept because it increases the efficiency of processors by allowing multiple instructions to be processed simultaneously. Understanding microarchitecture gives you a deeper ability to evaluate processor performance. Another crucial topic is parallelism. Modern computers rely on instruction-level parallelism, thread-level parallelism, and data-level parallelism to increase performance. When you understand how parallelism works, you can write software that takes advantage of multiple cores and advanced hardware features. This skill is valuable in fields such as machine learning, scientific computing, and systems engineering. Computer organization is also an essential part of learning computer architecture. Computer organization focuses on how components such as the central processing unit, memory, and input and output devices are physically structured. It explains how system buses work, how cache coherence is maintained, and how system performance is influenced by architectural decisions. Understanding computer organization equips you with practical knowledge about system design and troubleshooting. Another major topic you will learn in computer architecture is performance measurement. Performance in computing is measured using metrics such as latency, throughput, cycles per instruction, and clock speed. Understanding these metrics allows you to evaluate processors, optimize programs, and make informed decisions when selecting or upgrading hardware. This knowledge helps you work more intelligently with both hardware and software. Computer architecture also involves learning how data is represented inside the computer. You will explore binary numbers, hexadecimal numbers, signed and unsigned values, floating point representation, and more. Data representation is essential because every value processed by the computer is stored in a specific format, which influences accuracy, speed, and memory usage. When you understand data representation, you understand how computers interpret and manipulate information. You will also learn about control units. Control units coordinate how instructions are processed by generating control signals for each operation. There are different types of control units, such as hardwired control units and microprogrammed control units. Understanding how control units operate helps you understand the deeper workings of instruction execution and system design. Another important topic is bus architecture. The bus system facilitates communication between the processor, memory, and peripherals. Understanding bus architecture teaches you how data transfer occurs, how bottlenecks form, and how modern systems improve performance through advanced bus designs. This knowledge is crucial for building, upgrading, or troubleshooting computing systems. A very important concept in computer architecture is cache memory. Cache memory stores frequently accessed data to speed up processing. You will learn about cache levels, cache lines, mapping techniques, and replacement policies. When you understand cache memory, you can optimize your programs and understand why certain operations run faster than others. You will also explore virtual memory. Virtual memory expands the usable memory by storing inactive data temporarily on storage devices. This concept allows computers to run large programs and multitask effectively. Understanding virtual memory teaches you how operating systems manage memory, prevent crashes, and optimize resource usage. Another vital area is multiprocessing and multi-core systems. The shift from single-core processors to multi-core systems has changed how computers execute tasks. By learning how multi-core processors work, how threads are scheduled, and how synchronization is achieved, you become capable of designing efficient software and understanding system performance at a deeper level. You will also study storage systems. Storage includes hard drives, solid-state drives, and new technologies such as non-volatile memory express. Understanding storage systems allows you to differentiate between speed, durability, and performance characteristics. This knowledge helps you make informed decisions when selecting storage for different use cases. Network architecture also relates to computer architecture because modern systems rely heavily on interconnected devices. When you understand how computers communicate over networks, how protocols function, and how data is transferred securely, you gain the ability to design more reliable and efficient systems. As you learn computer architecture, you will also study power consumption and energy efficiency. Energy efficiency is a major concern in modern computing because devices must balance performance with battery life and thermal limits. Understanding power consumption helps you optimize systems and design energy-efficient hardware and software. In addition, you will explore reliability and fault tolerance. Modern systems must be able to detect errors, correct them, and continue running without failure. You will learn about redundancy, error-correcting codes, and reliable system design. This knowledge is vital for building robust systems in fields such as aviation, healthcare, and finance. Another important aspect of computer architecture is security. Hardware-level security features protect systems from attacks that software alone cannot prevent. You will learn about secure boot, trusted platform modules, encryption, and hardware-based isolation. Understanding these concepts helps you build more secure systems. Finally, before you leave, do not forget to subscribe to my channel to stay updated. Turn on notifications so that you will not miss my next video. Also, engage with my video by liking, commenting, and sharing it. Visit my channel to watch more helpful videos. Thank you very much for watching this video. Subscribe now before visiting my channel to watch my other helpful videos.